Okay, here we have problem 5.25. Let's look at it. Says the customer service department for a wholesale electronics outlet claims that 90% of all customer complaints are resolved to the satisfaction of the customer. In order to test this claim, a random sample of 15 customers who filed complaints is selected. Basically, what we have here, a store um, has a claim that 90% of all customer complaints are resolved to the satisfaction of the customer. 90%. Okay, we want to test this claim, and we're going to test this claim looking at the probability of different events that may occur. This is how we can test the claim. The claim is that the probability of success is 90%. Probability of failure is 1 minus 90%, or 1 minus 0.9, which is 0.1 or 10%. Okay, well, let's look at part B. Let's look at part 4 here. What we have is, this is just an inequality. This means x is greater than or equal to 9 and x is less than or equal to 12. What does that mean? That means x equals 9, 10, 11, and 12. We're looking at in between 9 and 12, inclusive, including 9 and 12. Okay, we need to find the probability of each one of these events to occur. With this problem, the easiest thing to do is just plug it in Megastat so we can visually see what we're looking at, what we're working with here. Okay, let's go to Megastat. You go to probability, you go to discrete, and I'm going to look at a binomial probability distribution. My number of trials in this problem happened to be 15. My probability of success happened to be 0.9. Click OK. Here we have the probability distribution represented here, and we need the values for probability x is equal to 9, 10, 11, and 12. We simply need to add those. There's several ways to add them. Probably the easiest way is you can type in equals sum parentheses, highlight 9 through 12, close parentheses, adds them all up. So the value is 0.18375. 0.18375 for this particular problem. And that's really it. Just to understand this, in terms of the original problem, what does that really mean? That really means that if I change this to a percent, 18.375 is your percent value here. We're saying that 18.375% of the time this event would occur, and the event of x being between, or the random variable being between 9 and 12. That's really all it refers to.